Hello, let's start with the experiment focal length of concave lens. So that is the formula. As you can see, the formula is 1 by v, 1 by f is equal to 1 by v minus 1 by u. And this is the observation table. Basically, you have to do 3 observations. So you are going to choose the object distance. So let it be, say for example, 8, 10 and 12. So you can choose 8, 9, 10, 9, 10, 11, anything like that. So for corresponding to these object distances, we have to find the image distance and apply the formula. So here this is the setup. So there is the bulb, that is the source of light, and this is the convex lens, and here we were going to keep the concave lens. So this is, as you can see, this is the concave lens. So basically it is thinner at the center. So since the concave lens produces virtual image, so we are using convex lens also. So both together, when used, we can find the focal length of the convex lens. So first what we have to do, so we have to keep the scale at 0 centimeter here. It should correspond to the grid. So this is our object, and we will place the convex lens in some distance. So there is no particular distance, any distance such, and also you should get basically the image. So you can see that that's the image, and note down the position of the image. So it's around 66 centimeter. So I'll note down the image. So position of image when only convex lens is there. So the position of the image is 66 centimeter. Now I will introduce the concave lens such that the object distance is 8 centimeter. So for concave lens, now this is the source. So basically, if the object distance has to be 8 centimeter and this is at 66 centimeter, I have to place this at 66 minus 8, 58 centimeter. So let me do that. Right. So now this is the concave lens. This is the source. So object distance is 8 centimeter. Now as you can see, the image is blurred. So before keeping the convex lens, it was more sharp, clear. Once I keep the concave lens, it becomes blurred. So what I have to do to find the image, I have to make the screen move backward. So as you can see, it is quite blurred. I'll go back. Yeah, this seems to be the image. This is more sharp. So note down what is the distance. So it's around 70 centimeter. So 70, that is the position. So image distance is 70 minus 58, so which is around 12. So 12 centimeter is the image distance corresponding to 8 centimeter object distance. Now for the next observation, you have to remove the concave lens, bring this back to the original position, which is 66 centimeter. So I have to bring this back to 66 centimeter. Now I have to make sure that the object distance is 10 centimeter. So that means 66 minus 10, 56. And then I have to again introduce the concave lens and repeat the whole process again. Now let us repeat the experiment again. For the second observation, I have chosen the object distance to be 10 centimeter. So this has to be at 66. So remember that whatever is on the screen, that is the object. So it should be placed at 66 centimeter because that was the position when there was no concave lens. So as you can see, I have noted down that already. So now 66 minus 10, so 56 centimeter. So I have placed the concave lens at 56 centimeter, and now as you can see, that's a blurred image. So I'll just push this back. Okay, you can see now the image has gotten clear somewhere around here. So around 74 centimeter, I guess. Yes, around 74 centimeter. So that means the image distance would be 74 minus 56, because 56 was the position of the concave lens. So this distance is now image distance. So 74 minus 56 gives me around 18. So for 10 centimeter, I'm getting 18 centimeter. Now for the last observations, again I have placed the object back to 66 centimeter position, and now I will place the concave lens such that the distance between them, which is the object distance, is around 12 centimeters. So I have placed it 54. So 66 minus 54 is 12 centimeter. Now you can see that the image is again blurred, and I will go back. So this seems to be clear, this is clearer. So this is around 78, you can see, okay, 78, 79 centimeter. It's around 79 centimeter. So that means the object distance is 79 minus 54. So it's around 25 centimeter. So those are our readings. So if I calculate the focal length for each of the observation, you can see that for the first observation I got around 23.8, and then minus 22.5, and then minus 23. So if I calculate average, I am getting average focal length of the concave lens is minus 23.1 centimeter. So this will be your result.